This is Algebra 2, Probability Lesson 5, Conditional Probability. So, conditional probability is going to be related to something we've already talked about, and that is the given, okay? When we looked at this with our dependent probabilities, we called this the probability of A given that B has already happened, right? That line means given that. And to calculate the probability of A given B, we need the probability of A and B divided by the probability of B. Okay? If we wanted to rephrase that, I'm also going to do it both ways just so that we have it. If you're trying to do the probability of B given A, it's still the probability of A and B, but then we're going to be dividing by the probability of A instead. Okay, so with that formula, let's try a couple of examples. Use the Venn diagram. We're going to look for the probability of A. So we've looked at Venn diagrams before. Remember, A is this whole circle here. So we would need to add those two regions. That gives us a 0.5. The probability of not A would be everything outside those two regions. So we could add them 0.3, 0.2 to get the 0.5. We could also do 1 minus 0.5. Either way, if there's a 50% chance that A happens, there is a 50% chance that A does not happen. Probability of B. So B would be everything in this circle over here. That is 0.3 and 0.1. So that is 0.4. Okay. There is a 40% chance of B happening. So there is a 60% chance of B not happening. Again, you can either do 1 minus the 0.4, or we could add the two regions that are not in B. 0.4 and 0.2 also gives us that same 0.6 answer. Letter E, the probability of A and B. Remember, our and is in the middle here. So our probability of A and B is 0.1. And now we have the probability of A or B. 3 ways to get that answer. We can use our formula from our addition rule. We could do A plus B minus A and B. That would look like 0.5 plus 0.4 minus 0.1. We could also add our 3 regions inside, or 1 minus our region outside. Either way, we get a 0.8. Now, all of that we've already done before. None of that was new. We're getting to the new stuff here, our given probabilities, the probability of A given B. Okay? Probability of A given B, I'm going to scroll up just a little bit, is the probability of A and B divided by the probability of B. So, based on what we've already written down, the probability of A and B is 0.1 divided by the probability of B was 0.4. And 0.1 divided by 0.4 looks like 0.25. If you wanted to look at the Venn diagram to see where those numbers come from, we're looking at just the B circle. So here's our B circle. That's the 0.4 in the denominator. And then what portion of that circle is also in A is just the 0.1 right here. So 0.1 out of 0.4, that is the probability of A, given that you're in the B circle. Okay? Looking at probability of B given A. I'm going to do some erasing here just so we can clean this up a little bit. We have the probability of B given A using our formulas. That's the probability of A and B, so still 0.1 in the numerator, out of the probability of A, that is a 0.5 in the denominator. If we divide 0.1 divided by 0.5, that looks like a 0.2. And if we wanted to see that represented in the Venn diagram, again, we're looking at just in this circle. What is the chance that you are also in B? 0.1 out of the A circle, out of the 0.5, is also in B. Example B, use the contingency table to find each probability. So I am looking at juniors and seniors and the vehicle that they drive. We have some cars, some trucks, some vans. I'm going to finish this table with some totals to help us with our probabilities. So I'm going to add in each column totals junior plus seniors cars, 23. Total, oh, he jumped. I don't like that. He keeps jumping. Well, I don't think this is going to look pretty. We'll do our best, okay? 23. If I write really big, I don't think he jumps. Okay. 7 plus 4, 11. 9 plus 7, 16. Close enough. Going across the rows, 8 plus 7 plus 9. Total juniors surveyed, 24. Going across the row, 15, 4, and 7. Total seniors surveyed, 26. So whether we total our juniors and seniors or total our cars, trucks, vans, we should get the same answer, and that is 50 total. Okay, with all of those numbers in our table, we can look at the probabilities. Probability from letter A, what is the probability that the student is a senior and drives a van? Okay, senior and drives a van. So we're looking at seniors that drive vans. That looks like 7 out of the total, which is 50. So out of all of the students, 7 are seniors that drive vans. What is the probability that a student drives a truck given that they are a senior? So if I'm looking at given that they are a senior, I don't care about any of this noise or any of this noise. If I'm looking at given that they are a senior, I'm only looking at the senior row. I'm looking at how many of them drive trucks out of how many altogether. 4 out of 26. Now remember, that's the probability of being a truck and senior. That's the 4 out of just the senior. I'm going to write that. I should have wrote that first. Probability of truck and senior divided by probability of senior. Okay? I'm going to do some erasing. Let's see if I can do this right. Didn't lose any of my totals. Looks good. Letter C. What is the probability that you are a junior given that you drive a car? The probability that you are a junior given that you drive a car. We need the probability that you are a junior and drive a car divided by the probability that you drive a car. Okay? That's our formula up top. Probability of A and B divided by the probability of B. So junior and car, bam. Car total, bam. We don't care about any of this or this or this for that third problem, right? Probability of junior and car is 8 out of probability of car, 23. You can reduce those fractions or get some decimals if you really want to, but it looks like that is all I have for these notes. Good luck on your exercises, and please let me know if you have any questions.